All right, so in this video, we are going to talk about how to factor out the greatest common factor. Now, hopefully you already have a good background of this, but hopefully this will help just a little bit more. So no matter what problem you're factoring, you always want to try to factor out a GCF first if you can, okay? You're always going to check to see if you can factor out a GCF. Now, first, you want to look at your numbers for your coefficients. So right here, we've got a 5. And over here, we would have a 1, okay? We do not have a number that we can factor out of these two terms, which is totally fine. For this one, our greatest common factor is going to be the x, because both of these terms have an x with them. So we can bring an x out front, and then what's left over, we're just going to take our x power, and it's going to go down by 1 since we're bringing one of the x's out front. So 5x squared is going to become just 5x. And then the minus x that we have there, that's just going to become minus 1 because our x is right here on the outside. Okay. If you factor out a GCF and then you end up in a situation where there's no x squared left, then you're done factoring. Okay. You always want to check for a GCF first, no matter what type of factoring you're doing. But if you do it and then there's no x squared left, then you're done. You don't have anything else to worry about, okay? Let's look at this one right here, 81x squared minus 9x. First, let's look at our numbers. We've got an 81 and a negative 9. Both of those have some factors in common, but the greatest common factor is a 9. We can factor a 9 out of both of those terms, okay? Now, if you want to do it in 2 different steps, you can start with just the number and then do the variables, see if there's a variable you can factor out. I'm going to do them both together. If there's also a variable you can factor out, like we have here, we have an x squared and an x. So both of our terms have an x. We can pull an x out front as well. And when we do that, our first term, when we divide that 81 by 9, that's going to give us 9 for our coefficient there. Okay. And then our x squared, when we take one of those x's out, we've just got an x left, okay? And then this minus 9x, we've taken out the 9 and the x, so it's just a minus 1, okay? That's it, all right? Now, because we don't have an x squared left, we've got an x and an x now, but we don't have an x squared left. That means we're done with our factoring. This is all we have to do for our factoring. So that's what you want to check for is, do I have any x squared left? If I don't, then once you take the GCF, you're done. Okay, let's look at one more. This one right here looks like it might be difference of squares at first glance. First, let's check for a GCF and see if that's right. Okay, so if we take the GCF, there's not a number we can factor out of 25 and 36, but they both have an x term, so we can factor out an x. So when we bring that x out front, we've got 25x minus 36. Now, if we're not careful, this still kind of looks like it's a difference of squares. We've got 25 and 36. Those are both perfect squares, and there's a difference in the middle. But the issue is with this term right here, if we try to take the square root, we are not going to get a perfect square because this x, we take the square root of 25x. Sure, the 25 part is a perfect square, but we've still got the square root of x left over, okay? That x does not go away, and it doesn't become x when you take the square root of it. You have to have an x squared to be able to take the square root and get a perfect square. So that's why something like this is not a difference of squares, and once you get to this point, you would be finished, okay? Hope that helps. You are in charge of teaching this to the rest of your crew. All right, and let me stop the recording. How do I do that?